This is a tornado. The wind in a tornado can blow at more than 100 miles an hour. But it's only moving air. How can air do so much damage? You can't see air, but it isn't nothing. It's real stuff. That's why it takes effort to blow up a balloon. This hovercraft is held up by air. There's a cushion of air held in by the black skirt round the bottom. What do you think causes all the spray? Why do you think little hovercraft is so manoeuvrable? Guess what's holding up this unidentified flying object? And this beach ball. It's bouncing on a stream of air blown out by a vacuum cleaner. Cut off the airstream and the ball drops. What is it that's pushing against the kite? Remember, wind is just moving air. Air isn't nothing. It's an invisible gas. You can't see it, but you can see what it does. Like all real stuff, air has mass. Enough mass to push round these heavy sails. And enough mass to do terrible damage if it's moving fast enough. Tornadoes are common in some parts of America, and schools have regular tornado practice. They know what damage air can do because of its mass. How could you measure the mass of air? This 2-litre plastic bottle has a mass of 150 grams. It's already full of air, but will the mass change if more air is pumped in? What do you think will happen to the mass when there's 3 times as much air inside as there was to begin with? With an extra 4 litres of air inside, guess what the mass is? Remember, it was 150 grams to start with. 155.7 grams. 5.7 grams more. And if you let the extra air out, why do you think carbon dioxide fire extinguishers need regular checks? Like air, carbon dioxide is a gas. What's he doing this for? Bubbles are full of gas. Some gases are heavier than air. Fill a bubble with a gas that's heavier than air, and it sinks. The gas has too much mass to float. But other gases are lighter than air. Why do bubbles filled with lighter-than-air gases float upwards? Because each bubble has less mass than the same volume of air. Why do you think smoke goes upwards? Smoke is like hot air. In the shadow of the candle flame, you can see the hot air and smoke floating upwards. Hot air is lighter than cold air. Remember, hot air rises. So which part of the oven would you expect to be the hottest? In the fridge, there's a cold metal plate at the top. This cools down the air near it, and the cold air sinks down the back of the fridge. By the time it gets to the bottom, the air has begun to warm up. So it rises up the front until it gets back to the cold metal plate. This air circulation is called a convection current. A fire or heater causes convection currents in a room. Hot air is lighter than cold air, so hot air from the fire floats up to the ceiling. Up by the ceiling, the air spreads out and sinks down again when it cools. Looking at this speeded up film, can you see how convection currents heat the whole room? Hot sunshine warms air near the ground. Currents of warm air float upwards. Many birds use the warm air currents to stay up for ages without flapping their wings. Rising currents of warm air are called thermals. Glider pilots use thermals to gain height. After casting off the tow rope, the glider has no power. How does the pilot manage to stop it falling down? Hang glider pilots use thermals too. When they find a thermal, they circle round and round inside it, gaining height all the time. What do you think it is that lifts these clouds up into the sky? And why do you think that it's during hot summers that we most often get thunderstorms? How could you use hot air to lift something up? Will the hot air from a hairdryer be enough to lift this dustbin bag? Almost. To get enough lift, you need hotter air. You can get very hot air by soaking cotton wool with alcohol and setting light to it. And this bin liner isn't as heavy as the dustbin bag. Will that help to make a good hot air balloon? You must take safety precautions when you're handling fire. Now, what will happen when the bin liner is filled with hot air? And what will happen when you blow out the flame and the air in the bag cools down? The trouble with small hot air balloons is that they don't have much lift. That's why these scientists are making a big one. Do you think bin liners are a sensible material to use? Does the colour of the material make any difference? What sort of materials would you choose to make a big balloon? Remember, it has to be airtight. You don't want the hot air to escape. How would you make enough hot air to fill it? The bottom end is sellotaped round a hoop to give the balloon a strong neck.
Now hold it. Can you go around there with the wind? Otherwise, just hold it there.
And the hot air from the fire is wafted into the balloon until it begins to rise up on its own. It's just like a thermal wrapped in a plastic bag.
Hot enough to let go at the end now? No? Yeah, go on, let go.
Big hot air balloons have much more lift than small ones. Can you guess why?
Hang on to it, girls.
This balloon had so much lift that it broke both its mooring ropes and floated off down the valley. They had hoped to attach a camera and take a photograph of the school from the air, but that project had to be put off till another day. What's the gas burner for? If you take a burner up with you, you can keep the air in the balloon very hot. Then you can lift a lot of weight. Can you guess why they don't use all the burners all the time? Even to lift one person, you need a burner. And quite a big balloon. Why does the balloon have to be so big? What sort of material would you use for the fabric of a big hot air balloon? And for the basket underneath? Could people use balloons for going to work? Or to school? Do you think hot air balloons could ever be useful? Or would it be better to use some other gas that's lighter than air? The first serious attempts at commercial aircraft were the airships. This one, the R-100, was built in 1929. She was 215 metres long and carried 55 passengers and crew all the way to Canada and back. R100 was to have been part of a fleet linking the far-flung corners of the British Empire. But these early airships were filled with hydrogen gas. Hydrogen is much lighter than air, but like the gas in these bubbles, it's dangerously inflammable. Several airships were destroyed in terrible fires. There is another gas you can use called helium. Like hydrogen, helium is lighter than air, but unlike hydrogen, helium doesn't catch fire. That's why helium is used today. Even though it's expensive, helium is what fills the gas bags of lighter-than-air craft like the Goodyear airship Europa. To get the lift they need takes more than 5,000 cubic metres of helium. That's more than 5 million litres. One disadvantage is that to carry just a few people, you do need a very large airship. But it makes a wonderfully quiet observation platform. Why don't airships make much noise? Unlike normal aircraft, an airship can hover in one place without burning up fuel. This makes it particularly useful for studying pollution, for example. They can take a whole laboratory full of equipment up with them, so the scientists have a super scientific eye in the sky. And at sports events, the airship can provide an ideal aerial viewpoint for television cameras. Airships don't fly very fast, but often it's an advantage to be able to fly slowly. Can you think when that might be useful? So, if you were able to borrow an airship, what would you use it for? Do you think airships are better than hot air balloons? And is there a future for craft that are lighter than air?